Let's look at number 59 in section 2.4. So I've already written the problem to save us a little bit of time. We're trying to find the values of a and b that make the function f continuous if f is defined as this piecewise defined function. And make sure, what we want to make sure of is that we understand what these three lines mean. So our function is going to look like x inverse, that is 1 over x, right? Remembering your exponent rules, for all x's that are less than or equal to -1, or sorry, less than -1. So I went ahead and drew some axes here. Think of this as your f of x axis or your y axis. Here's your x axis. And when x is -1, so from here to the left, our graph looks like the graph of 1 over x. That's x inverse, right? X inverse is equal to 1 over x. And for x greater than 1/2, our graph looks like x inverse, or 1 over x. So in this section of the graph, it's going to look like the graph of 1 over x. And the middle section is the part that we've got to figure out. We've got to figure out what a and what b are for x between and including -1 and 1/2. So in between here, in between x equals -1 and 1/2, our graph is going to be linear. And we just need to figure out those constants a and b that make it the right linear function to make this entire piecewise defined function continuous. So what we need to do is graph the parts that we know. The top and the bottom branches are determined. So for x greater than 1/2, here's x equal to 1/2. For x greater than 1/2, from here on out, the function looks like 1 over x. That's the flip it function, right? So when x is equal to 1/2, if I'm looking at the 1 over x function, if you take x is equal to 1/2 and flip that, or invert it, you get 2, except that I don't use this branch when x is equal to 1/2, so I go all the way up to that point, but not include it. And then the rest of the graph just looks like 1 over x. You can Desmos 1 over x if you haven't thought about that one in a while. Then for x less than -1, so for all of these x's, this whole portion of the graph is going to look like the graph of the inverse function 1 over x. So I'm not going up to x equals -1, but for everything below that, my graph looks like the graph of 1 over x. Okay, the whole graph of 1 over x, you know, is that it's a hyperbola, and it hugs up against the x and the y axes. Okay, so now I need to figure out how to essentially make this middle branch so that the whole function is continuous. And I do know one thing for sure about the middle branch, that it is linear. And the best way that I can think of to make a linear function that bridges this gap is to fill in this hole, and connect them with a line in between. And now this becomes a college algebra problem, because what is this? The coefficient, or the coordinates of this point, -1, -1, and the coordinates of this point are 1/2, 2. So we now need to find the line containing -1, -1, and 1/2, 2. Okay, so to do that, we need to find the slope and use one of those two, and use, well, and the equation of the line. Okay, so the slope is going to be y1 minus y2, x1 minus x2. And I did them in that order because I thought the arithmetic would be more convenient. I get 3 in the numerator. 1/2, actually plus 1, is going to be 3/2. When I resolve that compound fraction, that's stuff that you practiced in pre-calculus. You might want to review that. when I resolve that compound fraction, what I get is a slope of 2. So the equation is going to be y minus, I think I'll pick this point to make my equation with just because I don't have to deal with fractions. It'll be y minus y1, which would give me y plus 1 on this side, is equal to slope x minus x1, which is going to be y plus 1 on this side. And now if I need it, I still need to find a and b, so I need to get this equation in the form y equals, and then my slope times x plus my y-intercept. So all I have to do is distribute that 2, subtract the 1 over, and I get y equals 2x plus 1. So a is 2 and b is 1.